for this. The product rule is when one function is being multiplied by another, the derivative is the derivative of the first. We got to multiply that just by the second. So f prime times g, the derivative of the first function, times the second function. Then we got to add to that the derivative of the second function. What do you think comes after that? Times just the first function. It's a lot more involved than we were hoping, right? But that's okay. So let's practice it right here. I'm going to tell you, I'm going to call this one f, because that's the first function, and it's being multiplied. I'm going to go by blue, g. So if we've got two functions being multiplied together like this, in order to find the derivative, we have to take f prime. What would f prime be of this cute little function, 5x squared minus 2? Nice. He says, I remember. That's f prime. And I'm going to even write that underneath it. This right here, actually, I'll put that in black, is f prime. Times g. What is my g function? 8x plus 3. That's g. So we just did f prime times g. We need to add to that g prime times f. What would g prime be? Close. 8. Yep. So we'd have 8, and that's my g prime. Oops. Times, we got to multiply that by f. What was my f function? 5x squared minus 2. You guys, you did it. 5x squared minus 2. That is the derivative. We don't have to take it any further. Whew. That's the product rule. That's a lot to remember. Here's how my kids always remember it. Because we say f prime times g plus g prime times f. So we say f prime times g plus g prime times f. They call this rule fig plus gif. They see this as like an I. They call this fig plus gif every time. Fig plus gif just means the product rule. Will your college professor call this fig plus gif? They will not. They'll call it the product rule. So fig plus gif just kind of, it's a little helpful reminder to us if you want it. I'm going to do this one before I come up to these graphs. This one, let's practice that one more time. This is my first function. This is my second function. Since they're being multiplied together, we got to use the product rule. So j prime in this case would be f prime times g plus g prime times f. Let's go get f prime. 4 times g. A beautiful. That right there is f prime times g plus, now we got to go g prime. 6x squared, baby. 6x squared times f. Boom. Now, let's just remind ourselves, what the heck is this? This is insane. This right here is going to be like a x to the fourth graph. If I were to distribute this, this would be a parabola-esque. This right here will tell you the slope of this-ish parabola at any x value you would plug in your x. That's what this is going to tell you. Isn't that crazy? Let's do another. Is this a product rule function? Do we have two functions being multiplied together? To that, I'd say yes. You guys, this is a function and this is a function. They're being multiplied together. So in order to take that derivative, we've got to do fig plus gif. Here we go. We're always going to do it with respect to x first before we go plug in that pi. We got this, people. Derivative of x. Be 1x to the 0, so it's just going to be 1. Times g. You got it. Plus, excuse me, g prime, and we didn't review these words yet. Say it again. Negative sign. Kira remembers. The derivative of cosine is negative sign times f. Yes. So if you need to break this down, this was f prime times g plus this guy was g prime, and there's my f. We just did fig plus gif, people. We just did it. Now, if they just wanted g prime of x, we'd be done. They want g prime of pi. So I'm just going to go replace every x with a pi. I'm going to say, all right, g prime of pi is, instead of saying 1 cosine, I'm just going to say cosine of pi. Then I'm going to throw this x out front. I'm going to say minus, oops, instead of x, I'm going to say pi, cosine of pi. So, my bad. This is supposed to be sine. What's the sine at pi? The y value at pi is going to be 0. So this is just going to get me pi times 0. Final answer? You got it. So up here, I just want to let you know, I graphed this h of x for you. Is that really it? Yeah. I graphed this h of x. So could you guys just write, hey, this one's h of x. This one over here is h prime of x. From this function here. You guys. What would you say the slope of this h of x is here in the black? Would you say it's positive or negative? Positive. If this is a graph of h, you with me, Claire Cal? If this is a graph of h that has positive slope here, and this is h's slope graph, meaning these are the values of h's slope, and you said these were positive, it doesn't make sense that these y values are positive in the h prime graph of h. Again, this is saying the slope values of h's graph. Oh, Sev is so sad at me. The h, ready? Do you agree, Sev? All these slopes are positive. Yes. This is a graph of the slope values. Since these were all positive slopes, these values are positive. What is the slope here? What's the slope of the tangent line here? 0. Hey, guess what this value is right here? 0, exactly. Then what do my slopes do here? Negative, 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 and go back to 0. These are negative, 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 and go back to 0. This is at the exact same x value. This here is the same x value there. So these slope values, now, this messes with our heads so much, you guys. What would you say these slope values do here? They're 0, they get more negative, then they go back to 0, right? Isn't this 0 gets more negative, then goes back to 0? This messes with our head. If you're in AP Physics, you've got a leg up because I feel like you look at a lot of these graphs already. But if you're not, this is an eye to brain mess. What are the slopes here? Positive. They're positive, and they're at 0, and they get bigger, right? What is this y value? 0, and then these y values get more positive. This is weird to get your brain and eyes to understand, but I just wanted to expose us to it. We don't have to have it memorized. Let's flip the page. Here we go, y'all. I'm going to say, here's this function. H is f times g. They want h prime of 4. I don't want you to worry about that 4 yet. How do I get h prime of x if I've got f times g? I got to use the product rule. H prime. Here we go. The derivative of f times g. Oh, this kind of works out. What would f prime be? I'm actually just going to say f prime because my function is f. So we're going to say, all right, it'd be f prime times g. Oh, I guess we could put the x's in now when x is 4. It's fine. I'm going to write it. Oops. I'm going to back this up. I'm going to just put it in terms of x, but you could throw 4's in right now. F prime times g plus, what would product rule be then? G prime times f. You got it. G prime of x times f of x. Now, all of those x's need to get replaced by a 4. I apologize. We could have done this one in one step. My bad, my bad, my bad. Every x is going to get replaced with a 4. Then we're going to have to look at this graph. People, this is saying f prime of 4. The f graph, they have it pointing to this black line. F prime is referring to the slope. What is the slope of this f line when x is 4? Well, it doesn't matter because it's linear, so the slope is the same the whole time. What's our rise over our run? 1. So f prime of 4 is 1. Then I need g of 4. G of 4 is just a point. I'm going to do this pink line. G of 4 just says what is the y value when x is 4 on the pink line? 1. Agreed. Plus g prime of 4. What's the slope of this pink line when x is 4 the whole time because it is linear? Up 3 over 2, up 3 over 2. Agreed. My g f of 4, when x is 4, on my black line, the y is 2. Well said. 1 times 1 is 1. What about 3 halves times 2? Great. Final answer? Beautiful. I'm giving you some funky info. F of 2 is 2. F prime of 2 is 5. You're like, great. G is x cubed times f of x. And they want g prime. we got to go take a derivative of this. Do you agree? I've got one function. Because I do, I have to do product rule. This one you want to do in terms of x before we plug in any, they want a 2. We got to do this in terms of x first. Let's do it, people. G prime of x. We got to do fig plus gif. G prime of x. What would f prime be? 3x squared times g. I'm calling it g, even though our g in this case is f. Very good. We just did fig right there. F prime times G. We got to add to that G prime. Well said. F prime of X times F. Perfect. Look what we just did. I'm going to write it right here. This was F prime times G plus G prime times F. Fig plus GIF. At this point, they want to know what is G prime of 2. G prime of 2. I'm going to go plug a 2 in for every x. 2 in for every x. If I plug a 2 in right here. 2 squared times 3? 12. Times f of 2. I'm going to write it out. You guys might throw in values, but I'm just going to write it out so that I know where numbers are coming from. I plugged a 2 in for this x, and I plugged a 2 in for this x. Okay. Now I need f of 2. Did they give it to us? They gave it to us. So they got a rhyme for, they know what they're doing. 12 times 2 plus, did they give us f prime at 2? Great. 5 times 8. 24 plus 40. Final answer? 65.